Good morning. Here you can see I have written Lami's theorem, but here I am not going to teach you Lami's theorem. That was taught you earlier in my previous videos. You can see, you can watch that thing. Okay. Here the question is, as you have seen in the thumbnail, that can you use Lami's theorem for forces where forces is more than 3. Okay, can you apply Lami's theorem for more than 3 forces? That is the question. Can you apply Lami's theorem for more than 3 forces? Okay, so we know that there is a condition. Condition is what? There is a condition for which you can use Lami's theorem and otherwise not. What is the condition? All the forces should pass through a common point, a single point. Means all the forces should be collinear. All the forces should be lying on a plane. They should lie on a plane. Okay. Means all the forces should be coplanar. And number of forces should be 3. Is there any other condition? Yes, there is one more condition. That condition is, under the action of all these 3 forces, the body should be in equilibrium, whether it is static or dynamic. Okay? The body should be in equilibrium condition. Only for this condition you can apply Lami's theorem, otherwise not. But here in this lecture, my question is whether we can apply Lami's theorem where number of forces is more than 3, but other conditions remain the same. Other conditions means here all the forces, say we are taking an example where number of forces is 4. Where number of forces is 4. We are taking an example. Say here all the forces are coplanar, they are also collinear, and under the action of these 4 forces the body is in equilibrium, whether static or dynamic. Say we are talking about static equilibrium. Then we have to check whether we can apply Lami's theorem for this problem or not. Yes, of course, my answer is yes, we can apply Lami's theorem for the given problem. But you have to, what you have to do, you have to use Lami's theorem, number of forces should be 3. Okay, and here in the given problem, number of forces is 4. So you have to reduce one force. If number of forces is 5, then you have to reduce 2 forces. Means ultimately you have to create such a situation where number of forces is 3. So how you can do this? Yes, you can do this. Say number of forces is 4. So in that case, you take the resultant of any 2 forces. Whenever you are taking resultant of any 2 forces, then instead of 2 forces, you are getting only 1 force. So if number of forces is 4, then you take resultant of any 2 forces. So instead of 2, you are getting 1, and previously there were 2 more forces. So now at present number of forces becomes 3. And in that case you can apply Lami's theorem. So the same thing I am going to show you on this board. Okay. Say this is the point through which all the forces are acting. Right? These are the forces. Say this force is F1, this force is F2, this force is F3, and this force is F4. And the angle between the forces. Say angle between F1 and F2 is denoted by theta 1-2, theta suffix 1-2. Between 2 and 3, the angle is denoted by theta suffix 2-3. and between 3 and 4, the angle is denoted by theta suffix 3 dash 4, and between 4 and 1, the angle is denoted by theta suffix 4 dash 1. Right? Now say you take the resultant of F3 and F4. You take the resultant of F3 and F4. So resultant will be almost like this. Okay, this line represents the resultant of F3 and F4. Suppose this force is denoted by F suffix 3 dash 4. Resultant of F3 and F4. Okay. Now, so in the new problem, this is F1, this, okay, and this is F2. Angle is known, it is theta suffix 1 dash 2, and this is F3 4. This force is F3 4, 3 dash 4. Okay. Now you need to know this angle also. Okay, this angle should be known. Okay, since you are able to calculate the resultant, then angle also should be known easily. Am I right? Whenever you are going to calculate the resultant of F3 and F4, in that case you can also calculate the angle, this angle. Okay, just you calculate first this angle, only this angle. Okay, if you calculate this angle, then you add this angle with this theta 2 dash 3. You add this angle with theta 2 dash 3, so you will get this angle also. Okay, say this angle is denoted by only theta, or theta suffix n, n for new, n for new angle. New angle is how much? This angle plus theta 2 dash 3. So that is theta n. Now number of forces is how much? It is only 3, F1, F2 and this F3, 4. Okay. Now you can apply Lami's theorem as it is known to you. Okay. So this way you can solve the given problem. Whatever be the number of forces, if other conditions remains the same, if other conditions remain the same, that means all the forces must be collinear and they must be coplanar also. So this is the end of this lecture. At the end of this lecture, I want to ask you one question. If number of forces is less than 3, can you apply Lami's theorem in that case? That is the question. Okay. Whatever be your answer to this question, either yes or no, in both the cases, you have to explain. Okay. Without explanation, your answer is having no meaning. Okay, your answer has no meaning if you answer to this question just by guessing. Okay, yes, you guess, but whatever your guess, you have to prepare one correct explanation for your answer. Okay, so this is the end of this lecture. Thank you for watching this video.